Hey everyone, today we're going to go over inheritance. So inheritance is one of the main pillars in object-oriented programming, especially in languages like Java. What we do with inheritance is it allows the derivation of subclasses from existing classes. For example, in this case we have a person class, but we derive two more specialized classes underneath that, the student, which extends the person class, and the employee. So here we can see even student has subclasses, undergrad and grad. So what makes these different? Well, a person may have a name, an address, a phone number, and an email, but a student has all of those, and then in addition, they might have a college they go to, a major, and a GPA. Similarly, an employee, which is also a person, has all four of those fields, but they also have the salary, the date hired, and the office they work in. This is generally how subclasses are. We just simply attach additional fields and functionality to the existing fields and functionalities of the parent class. So when you derive a subclass, you form what's called an is-of relationship with the parent. So if we go back to an example here, a student is a person, right? An employee is a person as well. But that doesn't necessarily mean a person is an employee, because a person can be a student as well. So the relationship's kind of, it's easier to go down than, it's easier to go up than go down. If you know you're faculty, that definitely means you're an employee, okay? That also means you're a person. So this also brings me to my next point. If every class in Java is a child of the object class, so outside of whatever other class they might extend, every class in Java is a child of the object class. So what are the benefits of inheritance? Well, it allows us to define shared properties and actions only once. So if your parent already defined that property or action, then the child class may not necessarily have to redefine it unless they want to. Also, derived classes can perform the same actions as the base class without having to redefine the actions. Basically, point one. And then, if desired, actions can be redefined. We'll call this method overriding. We'll get into it later. So here we can see there's a person class. They have one field, their name. Default constructor is they have no name. And then we have a constructor where they do pass in a name. And then we have a set method and a get method and then a toString method. Or the student class extends with a keyword in Java, extends person. And they, on top of, we know person has a name field, a student class has ID, an integer field. Default constructor, and then their regular constructors, you pass in a name and you pass in an ID. What's interesting here is that we have this word super. So super refers to existing, here the super refers to the parent's constructor, the super constructor. And you simply pass in name and it will call on the person class name constructor. And then we can just simply set this ID to ID. So here we see a clever use of this. One of the benefits is just simply we don't have to redefine a new constructor. We use all the fields that we already know a person has, and we just simply call a constructor for the person on that. And then any new additional fields like ID, we simply set it in that constructor. And then down here we have this method called toString. And we have this weird notation here, an ampersand and then the keyword override. So that's because the parent class has the same method. It has a toString method. And you can see here, they also override. Why? Because every class in Java is a child of the object class. The object class does have a toString method. So when we redefine the toString method for the parent class, we have to put @override. And then we simply return the name. So that's the person class's toString. For the student class's toString, we override it, and instead of just returning the name, we also return the ID. Just to reiterate, to derive a subclass, we have to use the keyword extends. And so class, subclass, extends parent class. And that's generally how the format goes. And this makes the subclass inherit literally everything from the person class. And then now we also define the subclass is a parent class relationship. We've already talked about super earlier in the video, but this is just to reiterate so students can pause here if they want to read this slide. So this slide is talking about how a subclass can call a parent's functions. Like I said before, when we extend a class, we literally inherit everything from it. So here, the student Bob, we can call getName, and getName is not a class of the student class. It's a class. It's a function of the parent class. So even though a student the student class doesn't define it, a student is a person. So therefore, they can call Bob.getName. All right, we'll go back to overriding and overriding. We also have this thing called overloading. Overloading is when we have multiple functions of the same name, but they take different parameters. For example, here faculty class has two setName methods. They have a setName method with one parameter that takes in a string, but they also have a setName method that takes in two strings. And this is called overloading. Overloading occurs when two or more methods have the same name but have different parameters. They also have to have the same signature, right? So they have to return the same thing. Whereas overriding occurs when when a derived class defines a method with the same name and parameters as the base class. So here's just a small little trivia. Well, I guess not trivia, just a small little pop quiz. We have a class called base, and they have one method called display. So display just simply prints out base. And then we have a child class that extends the base class, and they do use the same method called display, and then they simply print out child. So if we initialize a new base variable and then initialize a new child variable, but then we define a third base variable called ref, and we point ref to the old base object b, what happens when we call display? Well, ref right now is pointing to a base class. So when we call ref.display, it's going to refer to the base class's display method. So in this case, it would print out base when we call ref.display here. Well then, what if we change the reference, right? We point it now to C. Well, C is a child class. So when we call ref.display, we see that ref is actually a child class. So we call the child class's display method. So that's going to print out child. So the answer in this case would be base and then child. So before I move on to the coding example, I just want to reiterate that the benefits of using inheritance in object-oriented programming is that it allows for more code reusability, and then it also makes the code a lot easier to read and understand, honestly, because it makes some sense. We have objects in the real world that do have a hierarchy, and when we establish that hierarchy, then it makes the code a lot easier to understand and easier to write. Plus, if we derive a child class and we don't like functionality of a parent, so for this code example, I'll be using this kind of hierarchy. We'll have a shape class that's going to be abstract, and I'll tell you what that means. And then we'll have two subclasses deriving from the shape class, circle and rectangle. And then from rectangle, we'll also have a square subclass. So if you're asked in an interview what a shape might be, you might want to ask them back clarifying questions. So if you did that, maybe they'll give you the hint. They'll be like, hey, a shape has two fields, x and a y. Maybe that will represent their position. And then they simply have get methods and set methods for the x's and y coordinates. And then they'll have a move to method, so the shape can move around on a 2D plane. Moreover, we'll have a move to method that any class that derives from a shape class has to implement. And then we'll have a draw method, a get area, and then get perimeter method. So if we were to start off with just the circle class over here, well, we just simply say class circle extends shape. And then we know a circle will have a radius. That really defines what a circle is. It's just a radius and a set of points around the center. So then when we call the constructor, we call the superconstructor of shape, which takes in an x and a y. But then we also just say we can call set radius, another method that basically says this dot radius equals radius. And then you can see this circle class also implements draw, get area, and perimeter like the shape class requires. Now, some of you might ask why the circle class doesn't implement move to, or our move to, and that's because we have already defined it in the shape class, the abstract class. So when we call circle dot our move to, we'll call the supers our move to, which will be shape.javas. Similarly for circle, we have a rectangle instead of a radius as a width and a height. We do everything the same. So there's really no difference. Just like the implementation of get perimeter will be different and get area, right? Because in get area for a circle, the formula is pi r squared, whereas for a rectangle, it's just simply width times height. Same logic applies for get perimeter. So if we go back to our hierarchy, a rectangle is a shape and a circle is a shape. And we know squares are rectangles, therefore squares are also shapes. So does square have to implement shape? Does it have to say, or sorry, not implement, does it have to extend shape? No, it just has to extend rectangle. So if we go to the square class here, we say square extends rectangle, and literally everything is the same, right? Except a square just has even length and width. So when we have top, left, and side, we simply call the rectangle's superconstructor for that. At this point, you guys are pretty familiar with it, so let's go think outside the box here. Can a class extend multiple parent classes? And the answer is no. Usually it's no. In languages like Java, it's a definite no. And this is because it can arise to some problems when we're calling functions, right? So let's say a circle class is not only a shape, but it's also some other parent class. But what if shape and that some other parent class of circle had a function of the same name? So when you call circle dot get whatever that function is, Java would be confused with which parent it wants to, the functionality of which parent it wants to use. So if you're trying to extend multiple classes, you can't do that in Java. However, what you can do is, even though a subclass can't extend multiple parent classes, it can implement multiple interfaces. So for interfaces, you don't really have to know that right now, but interfaces are simply contracts that in Java that make subclasses or any class define this, the fields and methods in the interface. They're similar to parent classes, except you can't really instantiate an interface, and that's really all you need to know for now. So just to reiterate, you can't extend multiple classes. You can only extend one class. If you try to extend multiple classes, you'll get a compiler error. You won't be able to run your code. And some of the last things I want to mention are that downcasting and also abstract classes. So for downcasting, if we go back to our picture, when we want to check an object or a variable in Java to see what kind of object it is, what I can say is we know if we have a reference to a shape, we're not guaranteed it's a circle or it's a rectangle. We don't know. But if we have a reference to a rectangle, we're guaranteed it's a shape. So let's say you have a shape reference and you want to check if it's a circle or a rectangle. You're going to have to use the keyword instance of. And that's pretty much it for that. For abstract classes, you just need to know you can't really instantiate them either. They're like interfaces. And that's pretty much it for this video. If you have any more questions, you can email me or you can just Google them. Cracking the Coding Interview has a brief chapter on it, but it doesn't really cover the details like in Java. But yeah.